All right, so it's 1:30. I guess we'll get started. I'll introduce myself. My name is Grant Sander. I am a PhD student in the math ed department here, so I hang out upstairs. Work with Dr. Carlson. You guys probably, some of you know who she is. A little bit with Dr. Thompson. So I'm going to give a presentation in 2 days, try to give a decent presentation on GeoGebra. Does anybody here use GeoGebra before or heard of it, know what it is? A few hands. So GeoGebra is similar to Graphic Calculator in that its main purpose is for teaching mathematics. There's some differences between this and Graphic Calculator. Actually, they're quite a bit different, which I'll talk about, and I think Dr. Thompson will come talk about that more next week. So I'm going to first give you guys kind of an overview of some of the things I've done with it, just in my own work as teaching mathematics and doing math ed research stuff. Just to show you guys some of there's way too many things to tell you what it can do, so I'm just going to show you a handful of them. So one of these, if you guys have worked in the Pathways curriculum via some of the courses, I don't know, 482 or 210, you may have familiarity with the bottle problem, or maybe you know this elsewhere. So this is one applet I made over the summer that you can change the different bottles and change different aspects of the bottle and then fill the bottle up with water. And this thing is actually sitting in 3D, so it's like a 3D little base with water. And then you can actually show the graph of the height versus volume. So I made this to have discussions with students about talking about how the height and volume of the water in the bottle change together, various things of this nature. So this is one use I've made, and this is probably one of my main uses of GeoGebra is creating applets of similar sorts to kind of center classroom discussion with students. It does a really nice job of presenting graphics and things. There's a lot of things you can make really easily in GeoGebra that are a little harder to make in Graphic Calculator. So it has some nice things there. And for the most part, everything's dynamic. So if I change my bottle over, you'll notice that I have the graph of height versus volume. So if I change various aspects of this, you'll notice that my graph actually changes as the bottle changes. So there's a lot of pieces that kind of move together, and a lot of it's dynamic, and there's a lot of communication between the different windows. So this is maybe one of the more complicated applets I've made. I don't expect you guys to be able to make something like this after 2 short days working with GeoGebra. This is kind of some of the power you can do with it. 2D view, 3D view, other things like that. Another big use for me, so one of my jobs is creating an online called GeoGebra/Pre-Calculus course. So I use GeoGebra all the time in creating things like, on the screen you see this little animation here with the little vase filling up with water. So I make a lot of these animations using GeoGebra. I should try to find a better one. It's like this one down here with the little tortoise and the hare racing. So I made that in GeoGebra and then recorded it with Camtasia, just exported it as a little video file. A lot of things of this nature. Also, GeoGebra has a really nice option. If you make a construction, you can export the image itself right out of GeoGebra into a nice high resolution image. So in my case, it's really convenient for creating a lot of images and really precise mathematical diagrams and adding nice aesthetic touches to it. Another nice use is if you're creating, if you're writing a test or a quiz, you want to have a graph of a function on there. It's really easy to create a function, adjust your axes and your grid and everything, and then export the whole graph out, and you can put that into a Word document, things like this. This is actually, I suppose if you guys are going out to teach high school, maybe one way in which GeoGebra could be really, really beneficial and save you a lot of time in creating things like that. And I'll show you guys how to do that because I think that's a really useful feature of it. And then GeoGebra is really nice because a lot of it is web-based. I'm not sure how many people will use this aspect of it, but GeoGebra can run totally within a web page, which is really kind of cool. Your students can you can send them a link to an applet and they can open everything in a web browser window. They don't have to have the software. So when you go out in the high schools, likely you're going to have constraints on what software you have. I know this is a complaint I hear from a lot of in-service high school teachers is their administrators won't approve downloading GeoGebra on the computers, even though it's free, and that's silly, but there's just weird things that happen in high schools. So a lot of this, you'll notice that you have basically full functionality of GeoGebra within a web browser, which is really nice. You can create things and just have students open it via a web browser. Just click on the link, it'll open up these applets in a new browser window, which I think is cool. I think in the past year and a half, GeoGebra has done a lot of work to make it pretty web accessible. I think for some of those exact reasons. All right, so that's kind of just some of the things I've done with GeoGebra. There's plenty of other things I use it for, but these are kind of some of the four main things I use it for. So what we're going to do now is, and Mark, did you end up sending that email out with the link? Okay, so Mark should have sent you guys an email I sent to him. I put together a presentation a month or so ago. And so if you have your computer open, if you click on that link, it should open up a Google Slides presentation. So that slides presentation, I think it's like 60 slides long. I try to just put a brief overview of GeoGebra to it. So I'm not going to follow these slides exactly in class, but it's a great reference if you're want to know more things or if you're having troubles with something. I try to put a bunch of different techniques and different aspects of GeoGebra into this thing. So you'll notice that on a lot of the slides, I have instructions, and I even put little animations in there to show you guys what is actually happening on my side of things. So Mark gave me the privilege to give you guys homework. I'm not going to give you a lot, but the homework will be out of this slide show, and there will be plenty of examples here. I encourage you guys, if you want to use GeoGebra outside of this class, just hold on to that link or send me an email to get the link again, and you can just use this as a reference if you want. So with that said, any questions so far before I start talking really fast? No? Okay. So if you have your computer or tablet open, we're just going to open up a new GeoGebra file. And I think it's going to be beneficial if you guys have it open and are kind of working along with me. It'll give you guys a little more of a genuine experience with it. And then it'll be less like me sitting at the computer talking while you guys hang out. So if you have GeoGebra open, and if you don't have the GeoGebra application, you can actually access it via the web. So if you guys have trouble downloading it, let me know. You can open it up through a web page, which is nice. All right, so if you have the desktop application, the Mac and Windows, or not Mac, yeah, Mac and Windows one should look about similar. They're pretty compatible. But once you open a new file, you'll notice this is the default view, so everybody should be looking at a pretty similar screen when they open it up. So there's a lot of different pieces to GeoGebra, and there's really no great way for me to go through these linearly, so I'm just going to start talking about whatever comes to my head, and then at the end try to mesh it all together, and hopefully it'll make some kind of sense. All right, so an overview of GeoGebra. Kind of the basics of GeoGebra is you define an object, so you create an object, like say a number or a point or a function, and then you can change different properties of that object. So if you have the graph of a function displayed on the screen, you can change the color of the graph, you can change the width of it, you can change different properties in terms of how it changes, things like this. And this is kind of the broad overview of GeoGebra. This is really all you're doing when you're creating GeoGebra things. You're creating objects, and you're changing aspects of the objects, and then you can create more objects and reference the other objects you've already made. So it's really not that complicated if you keep that in mind. Really all you're doing is creating objects. You can create other objects based on the objects you've already created. And there's kind of just dynamic interplay between the things you create. So that's really not much more complex than that. It's just getting to know what's going on in the GeoGebra screen. So right when you open it, you'll notice that on the left-hand side, there's a window that says Algebra. Algebra window just holds all of the objects that you create. So if you create a point and a function, it's going to display those two things in the Algebra window, and it's just like a lifetime list of all the objects you have defined. So algebra, you're really not doing algebra there. I don't know why they call it the Algebra window. I guess it kind of shows the algebraic view of the object, but really it's just a list of your objects. So I'm going to define a point. and this is a good time to talk about this. At the very bottom, there's a little input bar, right? It says input down there. And you can type things into that and hit enter, and then it's going to send it off to GeoGebra, and it's going to give you something back or give you an error. Yes, absolutely. So, for example, if I type something like A equals parentheses 1 comma 1, maybe let me change my display settings so you can see more of what I'm doing. There we go. Now you should be able to see what I'm typing. All right. So in the bottom, I typed A equals parentheses 1 comma 1, close the parentheses. So that's really just me defining a point. So I'm going to say I want to define an object. I'm going to name it A, and I'm going to make it a point whose coordinates are 1 comma 1. So if you type something like that, as simple as that, into the input bar and hit enter, it's going to create a point. It's going to place it at the coordinates 1 comma 1. And again, this is really all you're doing when you're using GeoGebra is you're creating objects like this, and then you can change various things about the object. So for example, this object can actually be moved around the screen. So if you click on A, you can move the point around the screen, and in your algebra view, it's actually updating the value of that object. So it's going to update the coordinates of point A and display that to you. So graphics view, as you can imagine, is really just like a Euclidean 2 space. It's really just the Cartesian plane. By default, when you create new objects, usually it's going to place that object in the graphics view. So like if you define a function, by default it's just going to show the graph of that function in that window. But you can hide those things and turn them off, which I'll get to in a little bit. So those are the 3 main components you're going to see right when you open it up. Yeah?
Can you like reset it to go back to what you typed in the first place?
So like Command Z, so like undo what you would usually do. So you can undo things to some degree. I think you might only be able to do that once, undo one action. Yeah, so Command Z will undo your most recent action. So now these are our 3 basic parts, and there's a lot more parts. There's a lot of other things you can hide and show and other windows you can show, but I'm just going to stick to these 3 for now. So I'm going to just show you guys kind of how to define some new objects that you'll probably use, like functions. You guys are probably going to want to define functions. So if you type something like g of x equals, I don't know, maybe x squared. If you type that into your input bar and hit enter, you'll see that in the algebra view, it created a new function. And then it's going to graph that function in your graphics view. There we go. So defining functions is really as easy as that. You just type whatever you want the function name to be, and you can actually choose the variable. So I can do something like h of, I don't know, w equals sine of w. And then it's going to graph it really, it sees it more or less like h of x equals sine of x, but then if you show that as a text, it'll use the variable w instead of x. But kind of the same thing as graphing calculator, where it doesn't matter what you use when you define a function. It's really just like a placeholder. And then when you start to type things like h of 3, it's just going to return sine of 3, things like this. So functions are pretty easy. You just type in more or less what you'd want to see in the algebra window, and it'll define those things for you. Yeah?
So if you want to edit that line, like say you were like, oh, never mind, I want to do cosine, not sine, is there a way to go in and like edit that, or do you just have to erase that and like write a line?
No, that's a great question. So there's a few different ways to change it. So in the algebra window, if you double click on that object, it'll highlight it, and then you can change it out to like maybe you wanted e raised to the cosine of w. And then you just hit enter and it'll redefine it for you. I think you should also be able to double click on the graph in the graphics window, and it'll pull up this little window that says redefine, and you can also do it that way.
Okay.
So there's a handful of different ways to do that.
Can you show us that? Can you just click like +1 or something?
Yeah, so let's do +3.
Sure.
And then when you hit enter, Algebra, it updates the function h, and then in the graphics view, it'll also update it. Also, another thing to note, by default, a lot of objects are what are considered free, which means you can drag them around the screen. Some objects are fixed, meaning you can't drag them around the screen. GeoGebra sees functions as free objects, which is maybe unproductive in a lot of cases, but just know that if you click on a function and start dragging it around, GeoGebra will let you like change the function, and it'll like update the function rule in the algebra window too. So just know that that's there. If you accidentally drag the function, notice that it is changing it, and then you can just do things like Command Z. Then there's a huge list of other commands you can enter into GeoGebra. So most objects are defined by, so I'm going to type a command and then talk about it. C equals, and then circle. As I'm typing circle in, it'll pop up this little window that has a bunch of suggestions for me. So it says, do you want to enter in a point and a radius number, or a point and a segment, or maybe 2 points? And there's a bunch of different ways to define a circle based on what you feed GeoGebra. So for example, if I feed it a point, we'll say A is the center point of our circle, and we want a radius of 2. So all I typed was C equals circle, center is A, radius is 2. I hit enter. It'll create a circle whose center point is A and radius is 2. So now if I drag A around, since the circle is defined in terms of A, the whole circle is going to move. So in this sense, you can define other objects relative to objects you already have on the screen, which is really nice. So you have dependencies, and as one thing changes, anything that's defined in terms of it will also change accordingly. So the general format, what I just showed you, where I type C equals circle, that circle is really a command. It's like you're going to give GeoGebra some information through like a function, and then it's going to return some object back to you. In this case, it returned a circle. So if you start to type things like S equals segment, maybe we want a segment between 2 points. So if you type segment, and then we notice our options are either 2 points or a point and a length, we'll go a segment between 2 points. So you can do something like, you have to feed it 2 points, so maybe we'll go from the origin, 0, 0, and we need to feed it another point, which is the end point of that segment. So we'll go to A. So now what I'm feeding GeoGebra is 2 points, the origin in the point A, and it's going to feed me back a segment that goes from the origin to point A. So when you hit enter, you'll notice that there will be a segment that goes between those 2 points. Since I defined that in terms of A, now as I move A around the screen, that segment's going to follow it.
Algebraically, is that its length that it's showing?
Yes, that's a great question. So in the algebra window, by default, some of these objects it's going to show different values, and so you'll notice that the segment S is assigned a number 5.14. That is just the length of that segment. So if you define like a shaded, like a polygon, a lot of times it's going to feed you back the area of the polygon. Or if you like shade in a circle, it'll usually display the area of the circle. So you'll notice that sometimes there's values up there that will give you like a number for a geometric object. Usually that's what, basically your first guess is going to be what it is displaying. So usually area or length, I think sometimes it'll do arc lengths if you define arcs, angle measures, things like that. Yeah?
So I'm trying to play around with this. I want to connect the circle, the center of the circle to the function g, anywhere in the function g. Like, how would you do that? Would you be able to?
Yeah, that's a great question. You guys are like guiding my discussion for me. It's great. I don't have to plan anything.
Future teachers.
Yes. So she asked, is there any way we can put the point A on the graph of the function g?
I tried that.
So there's actually a few different ways to do this. There's a way to put a point on an object so the point can't leave the object. Like you could drag the point along the graph of the function. So if we want to do that, I'm just going to create a new point. I'm just going to call it B. There's a command called point. And then you'll notice that one of the inputs is object. So if you feed it an object, it's going to put a point on that object. So for example, if I do B equals point, and then I just type in G for the object G, which is really a function, and then hit enter. It'll put a point on the graph of function G. So then you can drag B and you can change B, but only such that B always stays on the graph of G. So that's one way, or like if you have a circle, you can put a point on the circle. There's also a command, let me do another point, we'll call it D. There's a command called point in, which will put a point within a geometric object. So like if I do point in C, I'll put this point in here, and I can drag D around the circle, but D is confined to the circle that I put it in. So there's a lot of different ways you can do that. You can put points on segments, graphs of functions, circles, polygons, inside circles, a lot of things like this. So this is kind of, in general, kind of the basics of creating new objects, defining other objects in terms of the objects you already have. This is really kind of the name of the game with GeoGebra, or at least the basics of GeoGebra. So then you start to ask, what if I don't like the color green? Maybe green is my least favorite color and I want to make it pink and a thicker line so that my students can see it. So there's a little triangle wedge right here where graphics is. If you click on that, it'll drop down a little bar that has some options on it. Then if you click on an object, it'll put some basic properties there that you can change. So you might be able to guess that this green square corresponds to the green color of the graph of G. So maybe I change that to purple. Now the graph of G is purple. So again, if you click on G, it'll have this bar with a few different options on it, and you can start to change various aspects of G. So like maybe we want it a dashed line, and you can increase the thickness of the line with this little slider down here. Now you have a purple graph that's dashed.
What was that lock? It's like a lock.
Yes.
Is it just lock in place?
Yeah, so there's a little lock over here, and if you scroll over, it says Fix Object. Basically what that means is you can't move it. You can't drag it around. You can't change it. If you double click on it, it won't let you change it. It's like forever locked in there until you unlock it with the unlock button.
That's really helpful.
Yeah, so that can be very useful. You can make it so you can't actually change things. There's a lot of uses for that. So this is kind of like the basics of changing some of the looks of your objects. You can also right-click on them. Like if you right-click on the function, there's an object or a trace on, which means like if you have a point, if you turn the trace on and you drag the point around, it's going to trace that point. Or if you have a graph of a function, I just turn the trace on. As I move it around, it's going to trace my function out, which can be useful, maybe more so for points, but you can trace various objects. And then if you want to get rid of it, you can just zoom in and zoom out. It'll delete it.
How do you zoom in and zoom out?
That's a great question. Okay, so you can just scroll. Like if you have a mouse, just scroll in, or if you're using a trackpad, just 2-finger scroll in, scroll out. If you want to pan around the screen, click anywhere that's not on an object, like click anywhere in white space, and you can just click and drag, and it'll change the change your bases really. Yeah, if you guys have any questions, feel free to stop me. So I'm just trying to talk through a lot of the basics. So now if you right-click on an object, so we'll just right-click on the function G, it'll bring up this window where I turned the trace on, so I could turn that off if I wanted. But if you go to Object Properties, if you click on that, it'll pull up a big window. And this is pretty important. This is a pretty important window right here. This is really holds all the different object properties of that object, hence the name Object Properties. So you'll notice that there's 5 tabs up top. So you can change things like the basic tab, you can turn the trace off, you can fix the object, you can change the value of it. There's a color tab where you can change the color of it. So maybe I realized magenta is a better color than purple for now. You can change that there. There's a style tab. There's an algebra tab. Advanced tab, which has a bunch more things, which I'll talk about in a little bit. And then there's a scripting tab. So these are different options you have for changing the functionality of your object or different properties of your object, which I'll get to a little more right now. Mostly all I've talked about is the color and the style, but after a while I start to do some nice things with the advanced tab. All right, so I'm just going to try to get through a few more of the basic objects, and I'll have you guys start to work on something to get a little practice creating things. So surely you guys use sliders in Graphing Calculator. You can also create sliders in GeoGebra. And there's a handful of ways to do this. I'm actually going to delete everything I have on the screen. Don't be alarmed when I do this. I'm just going to clear up some space for myself. And if you want to know how I did that, you can just click on the objects in Algebra view and just hit delete on your keypad and it'll delete it.
Is it easy to bring them back if you put that by accident?
Yeah, so if you do Command Z, if you just do your undo command. And I think there's also, maybe not.
How far does it let you undo?
I'm not entirely sure. I think pretty far. How many? Okay, so I guess maybe you can do as many as you want in there. So now I'm just going to delete again. So with sliders, there's a handful of different ways to do this. You'll notice there's a bunch of buttons at the top, which I haven't touched yet. But with these, you can, each one of these has a drop-down window, and you can use these to create new objects. So you can have a point, and it's more like click and point where you want the point. So A, B, C, you can just click and point and create the objects with that. So there's a lot of different options for that up here. So lines, polygons, circles, things like that, which can be nice, especially if you're doing geometric constructions. And then there's one over here called slider. So one way to create a slider is just to click the slider button and then click on the screen where you want it. And then fill in all of the properties of this. So maybe we'll name the slider T. And then it'll ask you, all right, what do we want the interval to be? We'll go from -5 to 5, and then increment is really the step size of that slider. This is different from Graphing Calculator. In that Graphing Calculator, you choose how many steps you want. In this, you choose the step size you want. So if you want it to be pretty smooth, you just make a small number. And then you can hit apply, and it'll create a little slider on your screen. And you can drag the slider around and reposition it if you want. Maybe not. All right, so now I created a slider. You'll notice that in the algebra window, GeoGebra is really thinking of a slider as just a number, and the slider itself is just a way to adjust that number. So really you can call T as a number just like you did in Graphing Calculator. T is really just a number, and we have a slider displayed to change the value of it. So that's one way to create a slider, is just do this click and point option. There's also the option to do something like S equals, and then if you start typing slider, there's a slider command. And you'll notice you have a bunch of different options here. So minimum, maximum, increment, speed of the animation, width of the display. Do we want it to be an angle? Do we want it horizontal or vertical? Do we want it to be animating right now? Do we want the numbers to be random? So there's a lot of options there. You can actually ignore the back part of them if you don't want to do those ones. If you just want to indicate the starting, the ending, and the increment, just type in those as the first 3 commands, and it'll create a slider for you. So I'll show you. So if you go, we'll start at 0, we'll end at 2 pi, and we'll have our increment be 0.0001. That's all I'm going to give it, and it'll create a slider and put it on the screen for us. So now if you drag the slider, it goes from 0 to 2 pi, increments of whatever I told it to be, 1/1000th. So that's 2 ways to create sliders. Probably the most efficient ways to do that. And then like you guys have done in Graphing Calculator, you can start to use these slider values in other things that you do. So for example, maybe you do something like create a function f of x equals t. No, we'll do sine of t times x. And then you'll notice as we change the value of t, since that function is defined in terms of that slider, it'll change as you change t. Yeah.
Is there a way for you to set t? Like once you already have the slider on?
Yeah, that's actually it's something you'll really want to know how to do. There's a few different ways to do this. The most elementary way is to, in your input bar, type t equals, and then whatever you want the value to be. So for example, if you wanted t to be 0, if you just type t equals 0 in your command bar, it'll set t equal to 0. And it won't adjust your slider or anything.
And then you can just like change it out again afterwards.
Yep. So then if you start doing it again, it'll change as it was before. So you can do it with the command bar. You should also be able to double click in here and change it manually. So like maybe 2. And it's kind of the same idea. It's not going to change the slider itself. It's just going to change the actual, like the current value of t.
Is there a way for us to change the slider as well?
Yes. So if you right click on a slider and go into this object properties, which this is going to be a common thing we're going to do a lot, is right click on an object and go into the object properties. It'll bring up a bunch of different preferences for this object. So this one, it says, it's the tab you see up here in blue is called slider. So you can adjust different aspects of this slider. So maybe we actually wanted it to go from 0 to 2 pi in increments of pi over 4. Then you can change the slider that way. So you can change the like start and end values, the increment. You can actually change aspects like maybe we want the slider to be vertical instead of horizontal. So maybe you have your display is set up so you want it vertical. Maybe 200 pixels is too long. Maybe we'll go to 125. Now if you close out, you'll notice that my slider is actually vertical. I'm going to move this guy. If you can't move an object, it's likely because it's fixed. So if you right click and check the fix object off, you can drag the sliders around the screen. So now I have T and the slider is vertical. And then I have S, which was by default just horizontal. So there's a few different ways to create and adjust sliders. That's 2 ways to do that. And then of course you can create other objects based on the slider value, which is a pretty common thing to do. Let's see, what else is probably useful?
Did you say what random was for the slider?
I don't ever use random, but
I checked it and nothing seemed to happen.
I honestly have no idea what that does. I've never used it before. But it's there. I don't know. I'd have to Google that. Now I'm intrigued. There's also options, and this is a really nice feature. I like this feature a lot. You can put text boxes on the screen. And you can put the text boxes on there so that they reference like the values of objects that you have in the window. So you'll notice that there's a button up here with ABC on it. If you click on that and then point anywhere on the screen and just click, it'll bring up this window that allows you to put text in there. So like if you start typing like, hi, my name is Grant, you'll notice that it's going to show you the display of what it's going to look like before you hit enter, so you can know what it's going to look like before you do it. So you can do something as simple as that, like if you say, hi, my name is Grant, hit OK, it's just going to put a text box with that there. And then you can start to change things like the text size, text color, maybe a background of pink to make it unreadable. So you can do a lot of different things like that, which can be pretty handy, like if you want to label your axes or you want to put a label on an object or like a million other things you might want to do with text boxes. You can just put straight up text boxes on there. One nice thing about text boxes in GeoGebra 2 is I'm going to create a point. I'm just going to drop a point called A. If you go to the object properties of the text box, there's a tab that says position. And you might guess that's the position of where the text box is going to be, which is a pretty good guess. So if you put a point in there, and what this is looking for is a two-dimensional point. So if you feed it a point like 0, 0, it's going to put the text box at the origin. Or if you give it a point like A, which is the point we already defined, it's going to put this text box at this point A. So now as you drag A, it's actually going to drag the text box with it, and the text box is going to follow it. You can move the text box a little bit to like change the aesthetics of it, and it's still just going to follow A in the same way.
Can you take the label off of the point? Like,
Yes.
So you don't want to say A?
Yeah. So the easiest way to do that is if you click on A, there's a button up here that says Set Label Style, and you just go to Hidden for that, which I do almost with everything. Actually, I don't know if there's anything I don't do that with. So you can just hide it like that. You just click on it, and then
Could you like click over there like in point and type something other than A? Or does it have to just, it just labels it as A?
oh, this thing?
Yeah, or you could, I guess you could just type in the input.
Yeah, so input, you could type it to be whatever you want. That's actually a really, really good question. If you want to rename something, go to the Object Properties. In the Basic tab, you can actually change the name of it right there. Really nice thing about this is GeoGebra is going to change that name everywhere. So if you created other objects based on that object, it's going to go through and replace all of A with, maybe I'll change it to, I don't know. I could actually name it. You can feed it strings. Maybe there's 2 of me, so I'll put Grant 1. You can feed it subscripts as well. So now you'll notice that it changed the name to Grant 1. And it should be, if you go back to the position of this guy, it changed the starting point from A to Grant 1. So if you want to, if you like have remorse about naming something the way you named it, you can go in and change it. And really no consequences for doing that, which is really nice. So that's this like easy way to create text boxes. It's really easy to do. I'm going to do something else to it though. If you have a text box on the screen, if you double click on it, it's just going to pull up the editor window and you can change it. Just real quickly edit it. I don't know how many in here use LaTeX, but you can actually put LaTeX formulas in here. So something like, you can start to put mathematical formulas and stuff in there. So if you're fluent, or if you Google like LaTeX expressions, you can start to put nicer looking mathematical expressions and stuff in there, which is, I use quite a bit because I think it renders it nicely. So you can know that's there. Whether or not you'll use it, I don't know. Another really, really, really nice option about GeoGebra, something I think makes it really nice, is you can type things like the coordinates of point A, which is now Grant 1, is, now there's this little drop down tab that says objects. If you drop that down, it'll show all the objects that you've defined already. So if you click on Grant 1, it'll put the coordinates of Grant 1. So then when you hit OK, as you drag this pointer on the screen, the text is going to update with it, which is really, really nice. There's a lot of ways you can use that in really cool ways. It's like if you have a changing value, you can put a text box and do something like delta x equals whatever the value of delta x actually is. And then if you change delta x, that text box is going to update dynamically, which allows you to do some like really, really cool things that are pretty hard to do in other softwares.
It said you could change the speed of the slider. How do you play that?
That's a good question. So by default, these things aren't playing, but if you right-click on it, there's an animation on, and as soon as you hit animation on, it's just going to start playing that slider. And you can pause and play with the pause play button at the bottom left-hand side down here. So if you hit pause, it's just going to stop it. If you hit play again, it's going to start animating it again. So you can also, another really nice thing you can do is, I'm going to delete everything I have out of this text box and do something else. So blah, blah, blah. Now if you go to this objects window again, there's something called empty box. which it took me a little while to discover what this actually did until I clicked on it. If you click on empty box, it puts an empty box on the screen. What's nice about the empty box is if you type any object that's in your, like you've defined in GeoGebra, it's going to put the value of that object in the text where you have that empty box. So for example, if I hit S, S is something that we have defined in GeoGebra. It's going to feed back S, and as you update S, it's going to update that text. And then like if you put text afterwards, like blah, 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 as you update S, it's just going to look like it's right in there. It looks like you didn't even have to insert anything. You can also do really nice things like maybe you want to show the value of f of s. If you type f of s in there, it's going to evaluate f of s and put that value in that text box right there. So you can start to do things like f of x, f of s plus t squared divided by 5. Now as you adjust s, that number is going to update live time with it. So you can start to do other cool things like maybe your change in output as your like if you have a slider that's changing your input, then you can have like the change in output, the value of that actually displaying live time next to it, a bunch of other things like that. Basically anything that's changing in GeoGebra, you can just show its value in a text box, which is pretty nice. There's a lot of different uses of that. All right, so those are some of the basics. Trying to think what we have for a time. All right, I feel like I've been talking for a long time. So I'm going to have you guys, if you have that Google Slides presentation open, maybe we'll open up just real quickly, if you go to slide 40, a couple more concepts in GeoGebra. So maybe first we'll talk about, because this is a pretty easy thing to talk about and I think is useful for you guys. I'm just going to define a function, f of x equals e to the sine x, and just display that there. And what I'm going to do is just add a text box. I don't know, maybe I'll just say y equals f of x. And another one over here on the x-axis that says x. And maybe I want to put this like in a Word document. So there's a few ways to do this. So if you go to File, Export, you can export your applet or different aspects of your applet into different formats. So you can create a web page if you wanted to do that for some reason. Graphics view as picture, so you have a bunch of different file formats for that. So that's what I'll do first. If you go graphics view as picture, it's going to pull up a little window so you can choose some options. My favorite picture format is PNG, so I'm going to choose PNG. You can scale it, so you can choose how many units you want to be per 1 centimeter of your image. And then you can change your resolution. So I like to go pretty high resolution, so I'll go 600. There's a checkbox that says transparent. What that's going to do is going to make the background of your image transparent. So if you like put that PNG in something else, it's not going to have the white square behind it. It's going to be, if there's nothing there, it's just going to be blank space. And I'll show you what that does. So what I'm going to do is hit save. I'm just going to save it somewhere. I'm just going to save it to my desktop, title it, I don't know, TT, for no particular reason. Now if you open up this image, it'll just export the whatever was in your graphics window. And it'll put it in a picture format. And you'll notice that it has a gray background. That's only because my previewer has a gray background. So if you do something like copy that guy, and maybe I open up Keynote and have, I don't know, some crazy theme. Oh man, maybe black wasn't a great option. But if you paste that in, you're going to notice that I can't see most of it because my background is black, but I don't have a white background there. The background's totally transparent. So if you have a nicer looking background and it's not totally black, it's going to not have the white block behind it, which is pretty nice. So another option, and this is maybe quicker, if you do the file export, you can actually go graphics view to clipboard. So if you click on that, what it's really doing is like Control C, it's just copying your image. And if you go open up like a Microsoft Word document, and you go in and do paste, it'll paste the image right into your Word document for you, which is pretty nice if you're using Word. You can just surround it with text and everything, yeah.
I might be jumping the gun, but I'm really curious. What about animations when you change the slider? How did you do that? Or do we not know enough to do that?
Yeah, maybe I'll do that on Thursday, because that's a little more advanced.
Yeah.
But I will talk about that because I think that's a really cool option to do. So that's one way you can quickly just export these things, export them to Clipboard, and you can just throw them in your Word document or your slideshows, whatever you want to do with it. So that's kind of an aside, but also I think is a really useful feature, like when you start to adjust things like the display of your graph, or you can change the axes and stuff. I'll talk more about that on Thursday as well. That, or you guys can explore some of this just to get you started. If you right-click, if you're not clicked on an object and you just right-click somewhere, it'll have a menu, and one of the options is graphics with a little gear by it, which is really just like the preferences for the graphics window. You'll notice that there's a handful of different tabs. The first one, basic, you can change the dimensions that are displayed. You can change like the scaling of the axes. You can actually change the colors of your axes if you wanted to do that for some reason. Make them bold, change arrow styles, maybe make bold labels. Maybe you want your background to be, and you might use this for like printing purposes. I know that some, like if you have an older printer where you're at, sometimes it's nice to change some of these colors so it displays a little better. But you can start to change different aspects of your construction. So you can easily change the background, you can change the axes colors. You can show the grid, and you can actually change different aspects of the grid. If you just go into that graphics window and start to play with the preferences, you'll notice some of the things you can do. All right, so that was kind of an aside, but are nice things to know how to do. A few more objects that I want to talk about before we leave that I think are maybe the most powerful and most useful, in my opinion, in a lot of the work that I've done are sequences and lists. So you can create sequences like dynamic sequences that update as your construction updates. So you can have like a list that updates relative to like a slider value or maybe something you have on the screen. This becomes very, very handy if you want to display a lot of objects that are the same thing and are like defined in the same way. So like maybe you want to define 50 circles, and each circle has a center like somewhere and they all have the same radius. Instead of manually defining 50 circles, you can use a sequence to create 50 circles with one command, which is really nice. This is takes a little while getting used to it, but once you figure out how to use sequences, it becomes really, really powerful. So what I'm going to do is I'm going to create a function. I'm just going to call it, I don't know, f of x equals e to the sine x again. I'm going to create a slider. I'm going to go n equals slider. I'll go from 1 to 20 in increments of 1. So you notice my slider starts at 1, goes to 20. Each value is an integer value. So I'll give you guys a second to soak that in. Now what I'm going to do is I'm going to create a sequence, and you can create sequences of different types of objects. So you can create a sequence of numbers, a sequence of points, a sequence of segments, a sequence of circles, a sequence of sequences. I've done that before. There's basically any object you've defined like previously, you can create a sequence of those objects to create like an iterative sequence of these types of objects. So I'm just going to title my sequence SEQ. And then if you start typing sequence, you'll notice that there's a command called sequence. And so there's the first one you probably won't use. I think it just creates a sequence of numbers. There's another one that says expression, variable, start value, end value. This is generally the one I use. You can make it more fine-grained, but this is what we'll use for now. So really what sequences is doing is, if you've ever taken like a programming class, it's kind of the same thing as like a for loop. What it's going to do is you're going to choose a variable. So like I'm going to use I, and you choose the starting value of that variable. So I'm going to say, let I be a number that starts at 1 and takes and it increases by units of 1 until I reach the end value. And each time I is a certain value, you're going to create an expression, which is what you're going to feed it. And then it's just going to like start at I equals 1. It's going to create an object. Once it creates that object, it's going to increase to 2. It's going to do the same thing. It's going to create another object relative to I equals 2. And then increase again to I equals 3. And do this all the way up until you reach the ending value. So it's like you tell it where you want to start, where you want to end. And then you can use this variable I in your expression to create objects that are based on like the counter or the number I. So I'll just show you one use of how you might use this. Because it's kind of, when you first do it, it's kind of confusing to get used to the like syntax of typing things like this in. What I'm going to do is create a sequence of points, all of which are on the graph of f. Each one of them is going to be like, I'm going to plot the point 1, f of 1, 2, f of 2. So it's just like integer steps in the x. And I'm going to plot the point on the graph. So to create a point, you can just do round braces. I'm going to type I, comma, f of I. So now I have a point I, f of I. I'm going to tell GeoGebra that I want to use I as my variable in my sequence. So I'm going to type I. We're going to start at 1. What we're going to do is we're going to go all the way up to whatever the value of n is. So if n is 20, we're going to plot 20 points. If n is 10, we're going to plot 10 points. So we're going to use as our ending value whatever the value of n is. So if you hit enter, right now it just says 1 point at 1 comma f of 1. But if I increase n, you'll notice that the sequence changes accordingly. So it's going to have this list of points is going to update dynamically relative to this slider n.
What did you put in n? What did you type in sequence? I think I missed that part.
Yeah, so let me, here's what I typed in for.
Okay. To n, gotcha. Sorry, I just missed that last part.
It's all right. So I'll let you guys type this in so you get the, or you don't have to if you don't want to, but this is the general syntax for a sequence. You decide on the expression you want. So this, I did points, and I used I, which is my variable, so I tell it I'm using I. And I want I to start at 1 and jump in integer values all the way up to whatever the value of n is.
How do you do absolute value?
Absolute value, you can either do ABS parentheses, and it's like a function titled ABS, or you can just do straight bars like absolute value bars. So if you do shift backslash, whatever the like absolute value bars are, it'll actually recognize that as absolute value as well. So now this is a sequence and it updates relative to n. This is really convenient. You can do a lot of really, really cool things with this. So, I don't know, maybe this is a silly example, but I'm going to create a point A. Just going to throw a point on there. And then you could create a sequence. I'll just call it seq sub 2. You could create a sequence of, I don't know, points. I comma I will start at 1 and will end at whatever. I'm adding a few new things here. One of them is a floor function, which you guys have probably talked about already, right, in GC. So GeoGebra also recognizes floor and ceil as the floor and ceiling functions. There's another command, so I'm going to take the floor of some number. The number I'm going to take is the x-coordinate of this point A. So you guys probably also maybe did that in graphing calculator. You probably ended up using like dot products with the vector 1, 0. Maybe you guys didn't do that, but That's one way you could pull the x-coordinate of a point. GeoGebra has built-in functions called x and y, which will actually just pull the x and y coordinates of a point. So it kind of saves you a step in this process. So if you do x parentheses a, it'll pull the x-coordinate of a, and then we're taking the floor of whatever that value is. So now if I hit enter, as the x-coordinate of a increases, my sequence is going to grow in this manner that I told it to. If the x value of a is negative, it's not going to display anything because it starts at 1 and it ends at like -2. It doesn't recognize that. It gives you an empty sequence. So there's a lot of ways you can use sequences. You can use them in a lot of really nice ways. A lot of times I'll do things like, maybe I should pull up an applet. Where'd my Dropbox go? So this is one I've done where, and then you guys are going to do something similar to this at the end. This is relative to trig, and so these tick marks along the outside of the circle here are actually generated using a sequence of segments. So one of the things I can do is change the number of units in a rotation. So maybe I want to create a new unit of angle measure and call it GIPS. If you guys have been in the Pathways curriculum, you know what I'm talking about. Maybe I want 15 units to comprise a full rotation. So there's ways to use sequences based on numbers you already defined. So now I have 15 of these little tick marks around the outside of my circle. If I did something like 360 and made this look really ugly, you could create 360 of these guys. So sequences can be really, really useful in a lot of different ways. I use them a lot to, like if you're comparing two things, like if you want to measure one segment using another segment, you can use sequences to create these little tick marks on the top segment to imagine like you have a ruler, you're using one segment as a ruler for the other one. A lot of different things like this, you can use sequences pretty nicely, and it'll save you actually like a ton of time if you get really good at them.
I have a question. What window is that? It doesn't look like the algebra window we're working in.
Yes, I don't know how I didn't start with that, so let me start with that real quick. So yeah, you'll notice that this, what I have on the screen right now, looks quite a bit different than what you guys are looking at. That's a great question. I'm going to go back to my old one. So if you go to View, we've been looking at Input Bar, we've been looking at Graphics 1, we've been looking at the Algebra Window. Turns out there's actually like 8 more views you could look at. There's a spreadsheet view, which acts kind of like Excel. There's a computer algebra, which acts kind of like a really, really poor version of like Wolfram. It's not as strong, but you can do some computer algebra stuff. There's a second graphics window. Oh. So if you go to Graphics 2, if you click on that, it's going to open up another window. And Graphics 2 is really the same thing as Graphics 1, but it's in a separate window. And you can have objects in Graphics 1 and objects in Graphics 2. You can call them, like GeoGebra recognizes all of them. They can play together, but you don't have to display them on both. You can actually have like 2 different graphics windows open at the same time, which is really nice. You can do a lot of really cool things with that. Like maybe you have some situation playing on the right-hand side, and then on the left-hand side you have like a graph of 2 quantities being graphed out as the situation plays out. So there's a lot of really, really nice uses of that. I use it basically all the time. So if you go to View, you can toggle on and off some of these different views. So I'm going to turn Graphics View 2 off. There's a 3D graphics view, so you can create a handful of different 3D objects, so like spheres, cylinders, dodecahedrons, some various things like this. 3D functions, curves in 3 space. So if you open that up, it's just a pretty standard 3D view. By default, it's going to plot anything that's in Graphics 1 into the XY plane of 3D graphics, and you can turn that off. Probably won't get that to there until maybe Thursday, but there is that option. There's like a probability calculator that you can use with the spreadsheet and other things like this. So that's why some of my graphics or some of my applets look different than what you guys are seeing right now. It's because maybe I turned off the algebra view. Like if I'm going to present an applet or I'm going to use an applet in the classroom, usually I turn off the algebra view because the students don't really need to see like all of the various objects I've defined to create my construction. So usually I'll turn that off. If I have graphics 2 on, I'll turn that on and display some things over there. So that's how you do that. There's a little view option up in the very top toolbar, and you can toggle on and off different views. Any other questions? That was a good question. I'm glad you asked that.
I'm probably gonna have a lot of questions.
Okay. So we have about 3 minutes left. I'm trying to think. Yeah.
Can you input pictures?
Yes. That's. So there's a couple ways to do this. So if you find a picture you really like I really like these 2 cats. Oh, there's only one there. So if you copy the image and go into GeoGebra, it's from the edit. This is kind of counterintuitive for me, but if you go to edit, insert image from, you can either insert it from like a file if you have it saved on your computer, or if you copied it to your clipboard, you can insert it using that. And so it's going to put this little cat into your window, and you can do things like if you go to the object properties of this guy, there's going to be a position tab. And what you can do is indicate like where the bottom left corner is, where the bottom right corner is, and where the top left corner is. And it'll adjust the picture so that it's aligned with those 3 points. So like you could have something moving on the screen and you could attach your cat to it. So like I'm going to put the bottom left corner to be A and just delete out that guy. Now you can only see his paw. It's a huge cat. But yes, I don't know why he's so big, but yes. So it's nice to insert images. You can actually do a lot of really cool things with this. Like some of the things I showed you at the beginning with the tortoise and the hare running. There's a lot of images in there, like 2 flagpoles and a tortoise and a hare. So we're about out of time. So I was trying to decide if I wanted to give you guys something to do after each day, but I thought maybe I'll just give you a harder activity to do and just that's the only thing you have to do between today and Thursday. So maybe I'll let you guys pick which one you want to do. This one is kind of similar to what I showed you before. I don't know how well you can see that, but you can adjust the size of the circle and you choose how many units comprise a full rotation and you put the tick marks on the circle. Or I had another activity put together where you have 2 line segments. One like they're basically magnitudes. A is representing the magnitude of your numerator, B is the denominator, and then as you adjust B and A, you have these little tick marks that show measuring A in units of B. And then you can show the quotient on that as well. So does anybody have a strong preference for which one they would like to do? Circle?
Measuring sticks.
Okay, do whichever one you want, I guess. I don't know, that was an easy choice. I don't know why I didn't think at the beginning. So yeah, either do one or the other or both if you're feeling ambitious. These are maybe harder tasks than what we covered in class, but maybe at least try to start working on them before Thursday. You don't have to have them completed, but it'll be good if you have questions on Thursday. We can talk more pointedly about some of these issues. Cool? Any last questions? Yeah.
On this one, or wait, on the other one, what's that circle doing? Like the outside, that one is moving.
Oh, that's not in GeoGebra. That's in my screen recording software.
Okay.
It's just a magnifying glass.
That's
So
what
that you
I
can see.
thought, but I was like, I don't know if we did.
Yeah.
Okay.
No, yeah, that's.
Can you send an email of like which one we should do?
Yeah. I'll do that. 44 and 45. If slides 44 and 45. Yeah. What's that? Okay.
So they put the dots.
So yeah, I used
Type in, but it'll show like each point on that list.
Did you put anything up on there? Alright, I'll take a look
so right now all you have is F5. F5